Warm welcome learners. So in today's class we will solve questions of complex numbers. Let's solve some topicals. So we will start with this question. Given that u equals to a plus ib, w equals to c plus id, a, b, c are real, prove that bracket u plus w conjugate equals to u conjugate plus w conjugate. First of all, we should understand that if u equals to a plus ib, u star, that is u conjugate, will be equals to, just change the sign over here, a minus ib, right? So let's start with this one first. So what is u plus w whole conjugate? To find this, we have to first find u plus w. Yes or no? So u plus w equals to a plus ib plus c plus id. Now take the real part together. So this would be equals to a plus c plus I. If we take I common from both, it would be ib plus d. Are you here with me now? Understood till here? Now this is u plus w. This whole is u plus w. This is the real part and this is the non-real part. If I have to find the conjugate, just change this sign. So u plus w conjugate will be equals to real part, that is a plus c, minus I b plus d. Very good, very good. Now over here we will find u conjugate plus w conjugate. U conjugate would be, yes, speak, I'm hearing, a minus ib. Very good. So I will write a minus ib over here. And u conjugate would be, w conjugate would be c minus id. This would again be a plus c. If I take negative I common, it would become b plus d, right? Because negative is common outside. So sign will change. B plus d. Think with me. It was negative ib minus negative id. If I take negative I common, the sign will change and it will become b plus d. Hence, true. Let's move on to the next question. Alright. So in this question they are saying that solve the equation z plus 2 iota conjugate plus 2 plus iz equals to 0. Give your answer in x plus iy. X and y are real. Alright. Now listen. Let z be x plus iy. Okay. So I will replace this z, a complex number, with x plus iy. So this bracket, let me erase this one now. Replace z with x plus iy. I don't know value of x or y. Alright. Over here also I will put x plus iy. Now let's see what happens. X plus iy plus 2 plus I conjugate plus 2 plus I, x plus iy, see I have replaced z, equals to 0. Now tell me, this is real, right? These two are not real. So I write it like this, x plus 2. If it's a conjugate, the sign will change to minus I. Yes or no? Y plus 1. I've just changed the sign because this one will become x plus 2 plus iy plus 1. And if I have to find the conjugate, I've replaced the sign with negative. Now plus, multiply the brackets. 2 will be multiplied with both of them and the same with I will be multiplied by both of them. And remember, I square equals to minus 1. Okay, so this will become 2x plus 2iy plus ix. Now this is I into iy. That will become I square y, and I square is minus 1. So it will become minus y equals to 0. Yes or no? Now let's see, let's simplify it further. It will become x plus 2 minus iy minus I plus 2x minus y plus 2iy plus ix equals to 0. Now see, if we see this equal to sign over here, the real part is also 0 and the imaginary part is also 0. If we look carefully in this equation, x plus x is 3x and we have this negative y also as real part and we have this plus 2 also as real part. So 3x minus y plus 2 equals to 0. That will give us 3x minus y equals to negative 2. Yes or no? Now let's look at the imaginary part. What is the imaginary part? Minus iy minus I plus 2iy plus ix. Okay. So minus iy plus 2iy is iy. Very good. Minus I plus ix. Can I take I common from here? If I take I common, y minus 1 plus x. Now this part is imaginary, it will also equals to 0. I will send this one to the other end. X plus y equals to 1. Very good. We have the second equation. These two equations are here. Let us solve them simultaneously. 3x minus y equals to negative 2. X plus y equals to 1. Just add these equations. Y will cancel out. Negative y plus y cancels out. 4x equals to negative 1. X equals to negative 1 by 4. Just put it in this equation. So it would be negative 1 by 4 plus y equals to 1. Send this negative 4 to the other end. Y equals to 1 plus 1 by 4, that is 5 by 4. Now you have a value of x as well and you have value of y as well. Can we plug in into this form? The value of x was minus 1 by 4 plus I 5 by 4. This is your final answer. Alright learners, now let's try to solve this question. We have been given that there is a complex number denoted by a and the complex number is 2 plus yi, where y is a real number and y is less than 0. It is given that fa is this is a function. Simplified expression of fa we have to find in terms of y. So what we will do over here is we will replace this a by 2 plus yi. So it will become like this. Cube. See, I have replaced this a by 2 plus yi minus 2 plus yi whole square. See, oh, because over here is a square minus 2 times a, that is 2 times 2 plus yi. Now what can I do over here is I can apply direct identity of a plus b whole cube, or I can write this as this also, y times 2 plus yi whole square minus 2 plus yi whole square minus, just multiply it, it would be minus 4 minus 2 times this would be minus 2yi. Don't forget to replace the sign and change the sign. Now I will expand the square. A plus b whole square equals to a square plus b square plus 2ab. Okay, let's apply that. 2 plus yi a square plus b square. Okay, this is 2ab plus b square. So if I do b square, that is yi square, it would be y square I square. Now value of I square is negative 1. Yes or no? Value of I square is negative 1. So this whole term, this is negative 1. I will write negative y square over here minus the same thing because I'm expanding the square over here. Minus 4 minus 2yi. Now let's solve this one now. Multiply this 2 by all of them and then y by all of them, yi by all of them. So it will become 8 plus 8iy minus 2y square plus 4iy. Yes or no? Think about it. Plus no, not plus, minus 4y square minus I y cube. Why I y cube? Because see, yi times y square. So 3y we have and 1I we have. So we have this one. Now, when we open this bracket, the sign will change because minus is outside. I'm writing the same thing. Let me erase this one. So this would be minus 4 See, I'm changing the sign. Plus y square minus 4 minus 2y. Alright. So like term with like term now. First of all, let us use blue color for underlining the constant terms. This is constant and this one is constant and this one is constant. Okay. Now let us use black for the imaginary terms. Iy terms, Iy, and this is also Iy, and this is also Iy. Alright, let us use green color for y square terms. This is y square, this one is y square, and this one is y square. That leaves only one term alone, that is this one. This term is unique. When we solve the like terms, we will have negative y square minus 4y square plus 6iy minus iy cube. Let's solve these as well. So we will have negative 5y square plus, if we take I common from here, it would be 6y. See, 6y will remain, and minus y cube and I. So this is your final answer. Very good, learners. Now let's try to solve the B part of this question. What do we mean by this term RE? RE means real part of function equals to negative 20. What is the real part of the function? The function was negative 5y square and plus 6y minus y cube I. So this one is the imaginary part and this one is the real part. So negative 5y square equals to negative 20. This negative will cancel out. 5 times 1 and 4. Very good. Y square equals to 4. Y equals to plus minus 2 because y equals to square root of 4. That is equals to plus and minus 2. Now, it was given that y is less than 0. So we will consider y equals to negative 2. So our imaginary number, complex number would be 2 minus 2y. If I try to locate it, 2, positive 2 for x, and for the imaginary axis it would be negative 2. So the point would be somewhat here. And we have to calculate this angle. Now tell me, in the fourth quadrant, add sugar to coffee. How can we calculate the argument? The formula for argument is tan inverse b upon a, or we can say like this else also, tan inverse y upon x. So y over here is negative 2 over 2, and that too in tan inverse. If we try to calculate this angle, tan inverse negative 1 will give us negative pi by 4. So this is the argument of A. Show me a thumbs up, learners, till here. Let us proceed to the next question. Now let us try to solve this question. Solve the quadratic equation, giving your answers in the form x plus iy, where x and y are real. So there are various forms to solve this quadratic equation. I am using the quadratic formula. So what is the quadratic formula? X equals to minus b plus minus square root of b square minus 4ac upon 2a. Now let us recognize what is a, b and c in our equation. So if we look for the value of c, that is the coefficient of w square, that is a equals to 3 plus ii, 3 plus I. Now what is b? B is negative 2 over here. So I will write like this, b equals to negative 2. And what is C? C equals to 3 minus I. Yes or no? Let us put the value of ABC in the quadratic formula. So we will get W equals to minus minus 2 plus minus square root of B square, that is negative 2 square. Alright, minus 4 into A, that is 3 plus iota times by C, that is 3 minus I, divided by twice of A, 2 times 3 plus I. Now if I solve this further, it would be 2 plus minus square root of negative 2 square is 4, and we know that is A plus B and A minus B, so it would be minus, this would be 3 square minus I square, so it will give us 9 plus 1, that is 10. How come 9 plus 1? Because the value of I square is negative 1. So negative 1, negative, negative makes it positive, and we have 10 for it. Now we'll multiply this 10 by 4, so we will get 40. Yes or no? Upon twice of 3 plus I. This would give us 2 plus minus square root of negative 36 upon 6 plus 2 iota. Yes or no? Now, look very carefully. So this would give us 2 plus minus, what is square root of 36? It's 6. Because it is negative, so I'll put I. Can I write square root of negative 36 like this? Square root of 36 times square root of negative 1. And negative 1 is I. And square root of 36 is 6. So can I write it as 6I? Divided by 6 plus 2 iota. Alright. To convert this form, what should I do? We have two answers right now. 2 plus 6 iota upon 6 plus 2 iota. And we have 2 minus 6 iota upon 6 plus 2 iota. Right? To convert this, we will follow the same rule as rationalizing the denominator. If it plus is over here, we will multiply both numerator and denominator by minus. Minus of what? If it is 6 plus 2i, we will multiply numerator and denominator with 6 minus 2. Alright. So this is again a plus b, a minus b. What is a plus b times a minus b? It is a square minus b square. So I am solving the denominator first. The denominator will become 6 square, that is 36, minus 2i whole square. So 2 square is 4 times by I square, that is negative 1. So it would be negative 4, which will make the denominator 40. For the numerator, I am using a different color. And think with me, 2 times 6, 2 times 2i. 6i times 6, 6i times negative 2i. So what will it become? It will become 12 minus 4i plus 36i plus 12, which would give us 24 plus 32i upon 40. Take it separately, 24 upon 40 plus 32 upon 40i, which would give us in the simplest form 3 upon 5 plus 4 upon 5i. This is your final answer. The same one you can do for negative 1. The same process you can repeat for negative 1, and you will find your answer as negative I. So these are the solution. These are the solution of this quadratic equation. Let us move on to the next question. Complex number u is defined by u equals to 3 plus 2y, a minus 5y, where a is real. Express u in Cartesian form x plus iy, where x and y are in terms of a. Very simple, we know u equals to 3 plus 2y. upon a minus 5i, right? Now what we will do over here is the same process which we have done in the previous question. If minus is over here, we will multiply by positive. So a plus 5i, again a minus b, a plus b equals to a square minus b square. The denominator will become a square minus 5i square. 5 square is 25 times by I square. I square is negative 1. So it will become negative 25. And it will become a square plus 25, the denominator. Now let's talk about the numerator. 3 by a, 3 by 5, 2i by a, and 2i times 5i. So what will it become? 3a plus 15i plus 2ai minus 10. How come minus 10? 2i times 5i. 2 times 5 is 10. I times I is I square. Again negative, so negative 10. Yes, sir. Now, if we simplify it further, it will become 3a minus 10, right? Plus I and 15 plus 2a. Alright. Separate the imaginary part and the real part. 3a minus 10 upon a square plus 25. I'm just taking them separately. This upon this and this upon this. Plus 2a plus 15 upon a square plus 25. This is your answer. Now, we have been given the argument. Argument of u is 1 by 4y. We have to calculate the value of a. Alright, all of us know that argument equals to tan inverse y upon x. That is given to us pi by 4. So if we send 10 to the other side, it would be 10 pi by 4 equals to y upon x. What is y over here? Y is this part and x is this part. So 10 pi by 4 is, all of us know it is 1, equals to y, that is 2a. 2a plus 15 upon a square plus 25 divided by 3a minus 10 upon a square plus 25. KFC rule, keep, flip, change. 1 equals to 2a plus 15 upon a square plus 25. Flip it and change the sign. So it would be a square plus 25 upon 3a minus 10. These will be cancelled. Now solve it further. Send this to the other side because it is in division. Over there it will become in multiplication. So it would be 3a minus 10 times 1, that is the same number. 2a plus 15. Now this one will become 3a minus 10 equals to 2a plus 15. And this will become, keep the a on the one side, 2a will come here. Side changes, sign changes. So it would be 3a minus 2a. Side changes, sign changes. Side changes, sign changes. It would be a. Negative 10 will become positive. It will become 25. This is your answer. Let us move on to the next question now. Now, for this one, it is given that this equals to this, where a and lambda are real constant. Show that 3a square plus 4a minus 4 equals to 0. Now, in these type of questions, you might get confused, but no need to worry, I am here. No need to worry. I will tell you how to find the value of lambda in terms of a, because I want every value to be in terms of a, right? And this lambda is the problem. So let us solve the problem. We will send this to the other side. So it would be 2 plus 3ai equals to lambda times 2 minus I times a plus 2i. Yes or no? Multiply the brackets and multiply them by lambda as well. 2 by a, 2 by 2i minus I by a minus I by 2i, and all of them by lambda. So it will become, after multiplying, lambda 2a plus 4i minus ai plus 2, multiply lambda by all of the terms. It will become 2a lambda plus 4 lambda I minus a lambda I plus 2 lambda. Keep the real terms to the one side, segregate the terms. This is the rule, right? So it will become 2a lambda, this is real part, plus 2 lambda, this is also real part, plus 4 lambda minus a lambda I, this is the imaginary part. I just took out I common. Yes or no? Now look at it carefully. We know that the real part equals to 2. So 2 equals to 2a lambda plus 2 lambda. Alright. And we know that the imaginary part equals to 3a. So we have 3a equals to 4 lambda minus a lambda. Yes or no? Now, can I take 2 common from here and cut? So it would be 1 equals to a lambda plus lambda, and 1 equals to lambda a plus 1, and lambda equals to 1 upon a plus 1. Right? We know lambda in terms of a. Now we have to find the relation. How can we find the relation for this? How can we equate it equals to 0? Because look very carefully. We can say put the values over here, but there is no I over here, right? There is no imaginary part. So we will try a different way. We will put this value of lambda over here. Let's take lambda common. So it would be lambda 4 minus a. Yes or no? And we can put the value of lambda over here. Put it with me. So it would be 3a 1 upon a plus 1 times 4 minus a. You get a minus 1 to the other end. So it would be 3a times a plus 1 equals to 4 minus a. 3a by both, multiplied by both. 3a square plus 3a equals to 4 minus a. Take these terms to the other end, side changes, sign changes. 3a square minus a will become positive a, so it will be 4a. Minus a will become positive a, and 3a plus a equals to 4a. Minus 4 equals to 0. Minus 4, because 4 is positive, side changes, sign changes. And you've got this one also, learners. See? Very good. Very good. Clap for yourself. Now we will move on to the next question. Hence, now we will target these questions. Hence, find the possible values of a corresponding to the values of lambda. Really simple. 3a square plus 4a minus 4 equals to 0. You can put it directly in the calculator. I will use factorization. 3a minus 2, a plus 2 equals to 0. We'll put it equals to 0. 3a minus 2 equals to 0, and a plus 2 equals to 0. We will get a equals to 2 by 3 and a equals to negative 2. Now we will find the value of lambda as well. Lambda equals to 1 upon a plus 1. So lambda equals to 1 upon 2 by 3 plus 1, which would give us 3 by 5. And for the second part, we will have lambda equals to negative 1. Just put the value. See, if you put negative 2 plus 1 is negative 1. So negative 1 will be the answer. Right? So we have both the answers with us. That's all for part 1, learners. See you in part 2 now. Take care and don't forget to subscribe the channel.